So this question involves a proof, and we need to somehow show that the left-hand side is equal to the right-hand side. You'll notice the right-hand side has a 2 theta, and on the left we've got a 3 theta and a theta. So it looks like we're going to have to use the sum formulas, remembering that 3 theta can be written as theta plus 2 theta. It looks like that's how we're going to end up with the 2 theta on the right. Now, I suggest the first thing we do is we look for a common denominator so that we can add the two fractions. So it looks like the sine and the cosine will result in a common denominator of cosine theta, sine theta. So we can now write this as cosine theta times cosine 3 theta plus sine theta times sine 3 theta, all divided by sine theta cosine theta, which is our common denominator. Now that looks like it can take us somewhere, because now, remember, we can represent 3 theta as theta plus 2 theta. And then we can use the sum, or we can use, the sum formulas. So just let me remind you of the sum formulas. We know that sine A plus B gives you sine A cosine B plus cosine A sine B. And we know that cosine A plus B gives you cosine A cosine B minus sine A sine B. And we can use that, or we can use these two formulas to replace the cosine theta, the cosine 3 theta and the sine 3 theta. So let me rewrite this as cosine theta times cosine theta plus 2 theta plus sine theta multiplied by sine theta plus 2 theta. All of that divided by sine theta times cosine theta. So now we can use the sine expression to replace this, and the cosine expression to replace that. So that will give us cosine theta multiplied by cosine theta cosine 2 theta minus sine theta sine 2 theta plus sine theta multiplied by sine theta cosine 2 theta plus cosine theta sine 2 theta. And again, all of that is divided by sine theta cosine theta. So we're making progress, but our expression has become bigger, more complex. So remember, in the end, we want this to look like 2 cotan 2 theta. So we need to get rid of all the thetas, and we need to end up with 2 theta only. So if we look at the denominator, we've got sine theta cosine theta. Now that's a familiar expression. Let me remind you that sine 2a is 2 sine A cosine A, and cosine 2a is cosine squared A minus sine squared A. again, we can use these two expressions. So for example, the denominator, sine theta, cosine theta, that looks very much like that. So we can replace the denominator with half sine 2a. And I suppose we should multiply the cosine and multiply the sine and see if that simplifies our expression for us. So that looks like it's going to give me cosine squared theta, cosine 2 theta, minus sine theta, cosine theta, sine 2 theta, plus sine squared theta, cosine 2 theta, plus sine theta, cosine theta, sine 2 theta. So I just multiplied everything by sine. And then in the denominator, I can replace the sine theta, cosine theta with half sine 2 theta. So that's half sine theta, cosine theta. So it looks like it's become much more complex, but I think we can now simplify things. So let's see. So it looks like we have another of these sine theta 2 thetas, or sorry, sine theta, cosine theta, and we can replace each one of these with this term and this term are exactly the same. So they cancel out. So that's convenient. We can simply remove this term and that term, and they add up to 0. And the cosine 2 theta here and the cosine 2 theta there, you can take that as a common factor. I think we've almost finished now. We can say that's cosine 2 theta, common factor, into cosine squared theta plus sine squared theta divided by half sine 2 theta. That's 2 theta. So now, recognizing that this cosine squared plus sine squared is simply equal to 1 because of the identity, you end up with 1 over half being 2, so it's 2 cosine 2 theta over sine 2 theta, and cosine over sine is cotangent, so that's 2 times cotan 2 theta, and that's what we were asked to find in the question, so that's part A complete. Part B goes on to ask for a solution to this equation. Because it says hence, it means we can replace this expression with 2 cotan 2 theta. So we can simply say 2 cotan 2 theta equals 4, or cotan 2 theta equals 2, or tan 2 theta equals 1 over 2. So essentially it means taking the reciprocal of both sides. So tan theta equals half, or 2 theta equals the inverse tan of half. That's 2 theta 1. And we would then say 2 theta 2. They want it in radian degrees, so 2 theta 2 would be 180 plus 2 theta 1. So let's find 2 theta 1. So that's 26.6 degrees. They don't mention how many decimal places, but let's say 26.6 is fine. So 2 theta 2 is 180 plus 26.6, and that gives you 106.6. So now we know 2 theta 1 and 2 theta 2, we can now find theta 1 and theta 2 by dividing by 2. So that gives you 13.3, and this gives you 53.3 degrees. Have we finished? Now, because the question says between 90 and 180 degrees, so that means the 53 is acceptable, the 13.3 is unacceptable. We can still go on to find a further theta. So we can say 2 theta 3 is 180 plus the 106.6. So that's going to give you 286.6. And then we can divide that by 2 to find theta 3. It's 143.3. And that is acceptable within our range. So we can say the final answer is theta equals 53.3 degrees